First, we need to take a long board, carefully measure it, mark the center line, and cut it into 2 equal pieces to prepare the base for the next steps. And that's it! The board is now cut into 2 equal pieces, and we're ready to move on to the next step. So now we have 2 identical boards, and the next step is to carefully apply glue and join them together, making sure they are properly aligned and firmly pressed into a single solid piece. We apply glue to one side of the board that will be bonded to the other one. We bring the other piece of the board close and press the 2 parts together, making sure the glue spreads evenly across the bonding surface. Oops, it seems I added a bit too much glue, and now it's starting to ooze out from the edges of the boards. I quickly grab a clean cloth or a paper towel and carefully wipe away the excess glue, making sure the surface stays neat and ready for a strong bond. Now that we've carefully wiped away all the excess glue, we take the time to make sure both surfaces are perfectly level and aligned. Next, we grab a clamp and use it to press the 2 pieces of the board firmly together. As we tighten the clamp, we carefully adjust the position of the boards to ensure that the glued surfaces match perfectly and there are no gaps. Once everything is properly aligned and secure, we leave the boards clamped together for about 3 hours, allowing the glue to fully cure and form a strong, durable bond. After this, we'll be ready to move on to the next step in our project. We carefully release the workpiece from the clamp, and at first it seems that one part of the glued piece has stuck to one end of the clamp. For a moment, it looks like it might be a problem, but with a gentle and controlled movement of the hand, it easily comes free without any damage. Everything is fine, and the workpiece is now completely released and ready for the next step. We take a carpenter's square and carefully begin marking the measurements at 15mm intervals along the entire length of the workpiece. For these markings, we use a regular ballpoint pen instead of a pencil. A pencil can leave behind graphite traces on the surface, and graphite is electrically conductive, which could cause unwanted issues later on. Using a pen ensures clean, permanent marks and avoids any conductive residue, making the workpiece safer and more suitable for its future application. Following the marked points, we carefully draw horizontal lines across the workpiece. After that, we add vertical lines, making sure they intersect accurately with the horizontal ones. By doing this step by step, we create a neat, uniform grid pattern over the entire surface with a consistent spacing of 15mm, which will help ensure precision and accuracy in the next stages of the project. It's worth noting that this grid can be marked using other tools as well, such as fine markers or technical pens. Just make sure to avoid using a regular pencil, as it leaves behind conductive graphite, which is not suitable for this type of application. By performing this step carefully, one step at a time, we create a neat, uniform grid pattern across the entire surface with consistent 15mm spacing, which will help ensure precision and accuracy in the following stages of the project. So, we take a pack of copper nails and carefully open it, making sure not to spill them all over the place. We pour out an estimated amount by eye, selecting just enough nails to create the pins for our future nail board. These copper nails are perfect for this project because their material makes them ideal for soldering later on, allowing for strong and reliable electrical connections. So, we take a copper nail in our left hand and a hammer in our right, getting ready to start placing the nails on the board. Carefully, we position each nail at the intersections of the horizontal and vertical lines that we created earlier. We don't drive the nails in completely. Instead, we hammer them in about 30% of their length. This ensures that each nail is held firmly in the wood, while also preventing the board from splitting or cracking. Step by step, we continue this process, moving from one intersection to the next, making sure every nail is properly placed and secure. We repeat this until all the line intersections on the board are filled, creating a perfectly organized grid of nails that will serve as the base for our future project. It may look a little uneven at first, but we'll straighten it out later for a cleaner appearance. Since these are copper nails, they are soft and easy to adjust, allowing us to align them perfectly without any trouble. Now it's time to tin the heads of our copper nails. We set the soldering iron to 360 degrees Celsius and use solder that already contains flux, which makes the process very convenient. You can also apply flux to each nail head individually and then use regular solder. The quality of the soldering depends largely on the temperature of the soldering iron, so you'll notice when the temperature is just right, the solder flows perfectly and creates a strong, shiny connection. Look at the result. Nice, isn't it? Write in the comments if you managed to get the same outcome. All right, it's time to start soldering. Let's put together this cool circuit. By the way, you can see it in action by clicking the link that will appear at the top right of the screen. The water demonstrates how it's possible to turn a load on and off using just a touch. This works thanks to 3 key components in the circuit: 2 diodes, an N-channel MOSFET, a computer cooling fan, and 2 wires to supply power to the circuit. We take the N-channel MOSFET in our hands and carefully straighten its legs, testing them against the tinned heads of the copper nails, the pins we prepared for soldering. We solder the MOSFET using the same soldering iron temperature you experimented with when tinning the copper nail heads. First, we solder the leg labeled drain, then gate, and finally source, making sure each connection is secure and properly aligned. Additionally, on the pin where we soldered the source, we attach a short piece of negative wire, which will later be connected to the power supply's negative terminal, 12 volts. On the gate pin, we first solder one regular rectifier diode, and then the second diode, making sure to connect them in opposite directions so that the anode and cathode of each diode are properly aligned with the gate pin. The remaining anode and cathode ends are left exposed and twisted into loops in the air, making it easy to touch them with a finger. We take our computer cooling fan and solder its negative wire to the drain pin of the N-channel MOSFET that we soldered earlier. The positive wire of the fan is soldered to a free pin on our nail board. At the same point, we also attach the positive wire that will later be connected to the 12-volt power supply. In our hands, it may look like a tangle of wires, but behind it lies a neatly soldered, fully functional circuit that has been faithfully transferred from its diagram. We supply power from our 12-volt power supply, connecting the negative to the black wire and the positive to the red wire. Nothing smoked, which is a good sign. And the power supply shows no current draw because the computer cooling fan hasn't started spinning yet. We gently touch the exposed contacts of the regular rectifier diodes with a finger, and wonder of wonders, the circuit works. With just a touch, it turns on and off. Hooray, we did it! This method allows beginners to create organized, functional circuits step by step. Start by preparing the base with a grid of tinned copper nails, which makes positioning and soldering components easier. Always tin connections first, use the correct soldering temperature, and handle components carefully. Attach wires and components systematically, checking alignment and polarity. Take your time, avoid rushing, and test the circuit incrementally. Using this approach, even beginners can successfully assemble reliable circuits while learning proper soldering techniques, achieving a neat and functional result. Don't forget to like this video, subscribe to the channel, and try recreating the circuits featured on my channel.